We are back to finalize what we started in the first place. How do I mean? If you have watched my first video, I'll be linking it somewhere there. You would have seen and understood that I took time to explain all this and how we got to this point. So this time in this video, what I am going to do is to generate 3 equations, 1, 2, and 3. 3 equations that will be solved simultaneously by applying either substitution method or elimination method. So without wasting time, let's begin to consider the loop one at a time. All right? And the first loop we are going to consider is loop AB, and the rest, this junction. This junction is the loop we are going to consider. We have junction B. The loop there is what we are going to consider now, okay? But we are taking it from here. So the loop is A, B, C, D, okay? A, B, C, D, E, A. Back to E, A. That's the first loop, okay? Now, C, D, and then we have what? E, and finally back to A, right? So if we quickly trace this, let's take from here. That's the junction I'm talking about. If we take from this point or junction, we move in, our direction is going clockwise, right? So any arrow against or opposing our direction, we take a negative sign. So let's move. This, you can see the potential drop here is opposing our direction, okay? While the resistance of this resistor is just 10 ohms. So this is going to assume what? Minus sign. That's the potential drop. We have minus I1, R1, okay? We move again. This is also opposing our direction, right? So it's going to assume minus I2, right? R2. Then we take it down. This is D. Down again to this point. This is EA. Back to where we started. But this EMF, because it's in the same direction, all right, is going to assume plus E1 plus E1 all equal to 0. This is according to Kirchhoff's statements or laws. Now, what do? We are going to make E1. We are going to make E1 at this point, the subject, and it becomes E1 is equal to this turns to plus, and that is I1, R1. This turns to plus as well, and that is I2, and then R2. Good. All right? That is it. So we have succeeded in generating the first equation, right? This is the first equation according to this loop. Now the next thing we need to do for your learning pleasure and your understanding is to substitute wisely for us to generate a numerical or algebraic numeric expression that will form the first equation we are going to solve. And that is, for E, we have 10 volts. So we put 10 here, all right? For IR1, that is current 1 here, resistance 1 here is 10 ohms, and we are going to have 10 ohms, and then I, current 1. We move on again to substitute. That is for resistance 2, we have 20 ohms, that is I2. We have plus 20 ohms, I2, okay? With this, we have generated a numerical / algebraic, because of the terms I'm using now, okay? We can call this equation number 1, according to this loop, right? So we have generated equation number 1. Take note, this is equation 1. Also, We are going to generate another equation using this loop. Loop BCFB. The second one, this is the first one. Alright? The second one is loop BCFB. So we have second loop, loop BC, right? BCFB. So let's see what BCFB is all about. This is B, C, F, and back to B. So we are still working on junction B. Very, very interesting. So let's just do that quickly before we move on to the next one. So if we do that, also taking our direction, this is negative, all right? Taking our direction again, look at this. BC, right? FB, this is negative. This is also opposing our direction. It's going to take negative sign. We move down to this point, going to this way. This is in our own direction. It does not oppose our direction. So it's going to assume positive. So let's go. We have this. It becomes minus, right? This is going to be minus I1, resistance 1. Here is going to be minus I3, resistance 3, right? We come down here, this is going to be plus, all right, plus I4, resistance 4. I want to clean up this to create more space. Let's clean up this. We don't need it now. Okay, good. So, look at it. We have taken this, we have taken this, we are at this point, and we have taken this. That's what we have here. All right? All back to B again, right? That's the juncture. All equal to 0. Watch this. Very, very important. Watch it. But there is something we need to do here. There is something we need to do here. If you take it. So we still have minus I1, resistance 1, minus, look at I3. The I3 is a split. Is a split of I1 minus I2. So in place of I3, we will substitute in brackets or parentheses, so to say, depending on what I assume, I1 minus I2. So in place of I3, we are going to write I1, right, minus I2, parentheses close, and we have R3 plus I4, and then R4, right? We are making progress at this point. We are going to continue on the other side and see how things work out. Let me pick chalk. I have a lot of chalk here. Let's pick chalk. So there's something here we need to understand. Understanding this will help us to solve the remaining problem. Remember, we are talking about loop BCFB. This loop, we have taken care of this. We are taking care of this now. So let's click here and continue with that explanation, right? Let's look at what we're going to get. Very, very important. If we have understood these steps up to this point, now we are halfway solving the problem. What we need to do is to use R3, open the brackets, and then see what happens. So if we do that, we have, at this point, we have minus I1, R1, minus R3 multiplying this is going to give I1, R3, good. It multiplies this again, it's going to give minus I2, R3, good. So in that order, so we are done with opening the brackets, right? So the next thing we need to do is to put back. We retain our current 4, and then resistance 4, all equal to 0. Good. That's all. That is what it should be. And by the time we have this, and we are clear, right? We don't have any problem there. We move on to the next one. So we're done with this. Look at it. Just look at it. In case, look at the way we go. We move this way, this point, come down here to this point, move this way. That is it. And that is clear. So if we want to substitute, it's very simple, but before we substitute, we collect like terms. Terms that have some similarities, be collected together. This can go with these, right? Okay? So since we have one here, there's one also there. So we collect that. So we can collect that. One outside, bracket open, right? Let's see. So what goes in is R1 plus R3. Of course, because this minus is going to open this, it turns back to minus again. Then let's check here. We have I2R, okay? 3. So let's see. What happens if we have I4? So there's no split. We leave it that way. What we have is minus I2 R3, right? And then plus I4 R4 all equal to 0. That is it. This is 0. Okay? Good. So can we now substitute? Let's substitute. Minus I1 bracket R1 and then R3. This is R1. R1 is 10 ohms. R3 is 20 ohms. So we have 10 plus 20 is going to give 30 ohms. Okay? We just have to leave it that way. Here, what do we have? But instead of wasting time here, we just put it in the normal way. The normal way it should be minus 30 I1. Good. Then we come here. What do? Resistance 3. Look at resistance 3. Resistance 3 is 20 again as well. So we move on and put resistance 3, which is 20 I2. Good. Then resistance 4, what do we get? Resistance 4. Where is resistance 4? Look at resistance 4. It's 40 ohms. So we have 40 ohms. 40 ohms. That is a I4 all equal to 0. Good. So look at this. We have generated another equation. Look at it. We have generated another equation, and that should be our second equation. Let me draw this line very well. Look at it. That's second equation. Very simple. Okay, we've gotten first one here, right? When I have the second one, then the next thing we're going to do is to get the third one, and we are done. So our next loop for consideration is loop C, D, F, C. So we're going to look at loop C, D, F, C. Okay? I need chalk. So the third loop is C, D, F, C, right? That's what we're going to do. C, D, F, C. Let's see what we do. Take this direction, clockwise direction once again. If we take a clockwise direction, this is opposing our direction. It means minus I2, R2. Good. We move again to this point. Coming to this point, you can see if we come to this point, this is moving in the same direction. All right? So we have it as plus. It's moving in the same direction. We have it as plus I5, R5. We move again at this point. We are taking C, D, F, C, right? That's what we're taking. That's the loop. So moving from this point up, look at it. Up, the same direction. The arrow is showing it. The same direction, so it should be positive. We have plus I3, right? R3 all equal to 0. But there is something we need to take into consideration here. We're going to do small analysis here, all right? But before I go further explaining this or simplifying this, I suppose you are getting something from this. Why don't you subscribe? Why don't you give some thumbs up? Come on. Put on the bell button for constant notification. Alright? Share with your students, friends, networks. Learning make it a man. I love this. Alright, so let's fall back to this. There is some analysis. We need to analyze what happens in current 5. We need to analyze what happens in current 3. Very, very important. So let's begin without wasting time. Here we have I2, we retain I2, R2, but we are going to split these. Look at this. Current 5. Alright? Is split into current 4 plus 3. So in place of current 5, we split current 4. We substitute with current 4 and then current 3. Then R5. Good. Alright? The same thing happens here. We are going to split this current. Alright? I want us to see it very well. We're going to split that part because it's the part that we show how we explain what happens there. For 3, current 3 is splitting into 1 minus 2 into brackets. So we have 1, all right, bracket open, current 1 minus current 2, all right, close, R3 all equal to 0. Good. This is absolutely interesting. Let's look at it very well. So what do? We are going to open